Hey everyone, welcome to the first lesson of the new unit. This is going to focus on taking what we already know and making it a little bit more simplified, for lack of a better word. In order to start talking about what condensed structures mean, we've already kind of been doing it, but I really want to emphasize us getting used to this. I'm going to go ahead and define what a Lewis structure is, even though I know we know what that means. But a Lewis structure is a pictorial description of a molecule that shows the relationship between atoms of a molecule and the lone pairs of a molecule. And again, Lewis structures can be really big, they can be really small, but an example I'm going to give of this, and again, I'm doing this because we're gonna simplify these Lewis structures a little bit, is CH3COOH, which is acetic acid. And the Lewis structure looks something like this, or this is how we've been trained to kind of think about the Lewis structure. Each of these is in octet, 2 lone pairs on that oxygen. This is how we've kind of been trained to draw and picture what molecules look like. We're going to start getting into learning what a condensed structure is. And I'm going to call the first one partial condensed, and then we'll look at what a fully condensed one looks like. A lot of the times, it's really tedious to draw every single atom, every single line to represent these organic compounds. So if we want to simplify this Lewis structure up here, we can use what's called a partially condensed structure. And a partially condensed structure contains no lone pairs, so you don't have to draw those. It should be obvious which ones have lone pairs, which atoms have lone pairs and which ones don't. And we can infer the number of lone pairs based on the octet rule. Again, more often than not, things are going to fall into octet. We can just use octet to help us. And no bonds to hydrogens are shown. So again, hydrogen's kind of that we don't really care about you because we know that you're just there. Not only are the bonds aren't showed, the hydrogens are just placed next to the atom that they're attached to. So if we wanted to come up with a partially condensed structure for acetic acid, again, we just drew the Lewis structure for it, CH3COOH, which is acetic acid. If we wanted to draw the partially condensed structure, we can take out sorry, I should have put a lone pair up here. The lone pair on the oxygens. Sorry about that. We could take out the lone pair on the oxygens, And instead of drawing the actual bonds to the hydrogens, we can just add our hydrogens right next to the atom that they're attached to. Okay? So this is the partially condensed structure. Notice that there are no lone pairs. And the hydrogens have no bonds. Again, quicker way to kind of tell us what it looks like. And the last thing that we want to talk about is this idea of a fully condensed structure. Okay. And these are, again, mostly meant for typing purposes. A lot of the times when organic chemists are using these, it's really impossible to actually draw these out on the computer. But here we have no single bonds drawn. And then sometimes multi-bonds are drawn. But again, we'll cross that bridge when we get there. And again, if we want to do an example of this, we can use CH3COOH, and we'll actually notice something really quickly. If we take out all the bonds in this partially condensed structure, and we kind of go in order of where the atoms are, we have a CH3 on one side, a C, two O's, and an H. Okay. I know what you might be thinking. It's really similar to the chemical formula, but it actually goes in order of the structure. So it's literally just the elements in there in order of how they look in either the partially condensed or the Lewis structure. But officially, this is what is known as the condensed structure. And I would argue that more often than not, sometimes chemical formulas equal condensed structures. However, chemical formulas don't necessarily go in order of the structure. For instance, if we had acetic acid, which is CH3COOH, we could write the formula a little differently. All it has to have are 2 carbons, 4 hydrogens, and 2 oxygens. This is also acetic acid because the chemical formula is just telling us the elements that are in there. You know, you could have done CH2CH2O2. They're the same thing. But this is no longer the condensed formula. The condensed structure. The condensed structure must go in order to the best of the ability as the structure itself. Okay? Let's do an example. And let's do something like isopropanol. So isopropanol, propanol. Isopropanol has a pretty interesting Lewis structure. It's actually a little cute if you ask me. So we have carbon attached to 3 hydrogens, attached to 2 carbons. 1 carbon has a hydrogen bond to it, or an alcohol group, as we'll learn pretty soon. So this is the Lewis structure for isopropanol. If we do the partially condensed, again, we're just getting rid of those bonds to the hydrogens, and we don't want to put any lone pairs there. So we have H3C, CH, CH3, OH. Notice here how I try to connect at least one of them as the carbon-carbon bond. This technically is incorrect because the hydrogen's not really attached to the carbon's attached to the carbons. So we'll talk about this when we get back from Thanksgiving. And the last one we have is fully condensed. If we want to make this even smaller for typing purposes, we can say it's CH3, HOH, CH3. I forgot a C in here. Notice how we have 2 groups that are exactly the same, CH3 and CH3. In this case, we can put them in parentheses, put a 2, because we have 2 groups, and then CHOH. And that's all I have for you. Please work on the activity and the worksheet and watch the next video as well.